Welcome to the viewers. Now we discuss Eulerian or spatial method for deformation. Now here, if we earlier study the Lagrangian method, there these rectangular coordinate systems of a spatial point small x1, x2, x3 with a function of capital X1, x2, x3 in the material point and time. But here it will be reversed, that is material point capital X1, x2, x3 are functions of small x1, x2, x3, the spatial points, which are spatial points, at time t. That is a deformed state. So if we take undeformed state to deformed state, that's in this particular cases, if we consider that is x1 material point is the function of spatial point x1, x2, x3 and t, and capital X2, that's the material point x1, x2, x3 and time t, and capital X3 is the function of x1, x2, x3 and t. So compactly we can write xy, capital Xi, that is a function of material point xi, x1, x2, x3, that's a spatial point, and time t for I runs from 1 to 3 in this way. And as well as the velocity small vi in Eulerian cases, vi is the function of small x1, x2, x3 and t. It is also a concept for I runs from 1 to 3 in the spatial coordinate. So in the material point, in the undeformed state t equals to 0, that means x1, x2, x3, that's undeformed state, at time t equals to 0 and passes to the deformed state. This coordinate system has a position. If we take a position p, that will transform to x1, x2, x3. That's an undeformed state, and it is deformed state. And as well as this type of position, a spatial points, that's an x1, x2, x3 with the velocity v1, v2, v3. And in Eulerian cases it is insignificant, and we can, in the Eulerian cases we can see that this capital x1, x2, x3 are irrelevant, and the spatial coordinates, that's x1, x2, x3, where the material point resides at time to serve the purpose, small x1, x2, x3. For a fixed time t, we have xi, that's some spatial coordinates moving with the material coordinate capital x1, x2, x3, and in the Eulerian concept xi, capital Xi with the spatial coordinate x1, x2, x3. We find these two in this equation of configurations. And now on the contrary, you see the deformation, strain deformation, and such deformation occurrence into the relative displacement, that's called the strain deformations. And if we see here at any time and body, and that will be deformed to this type of body, that's called the sum of the deformations, and that deformations is displaced by uy of the material point. If we say x1, x2, x3 material points, at t equals to 0, and in the undeformed t equals to 0 undeformed state of the position x1, x2, x3, in the deformed state at time t, then uy is equal to, that is xi minus capital Xi. I runs from 1 to 3, and that means this Lagrangian method, number one case, Lagrangian method, material coordinate. So uy is the function of x1, x2, x3 and time t, and xi is the function of x1, x2, x3 and time t minus xi. And in cases of Eulerian method, that is uy is the function of spatial coordinate x1, x2, x3 and time t, and here xi and capital Xi is the function of x1, x2, x3 and t. So in this way we get some of the idea about the displacement, and very useful for the deformations. Now in the next video we discuss many topics regarding this, like strain deformations and everything else. Now keep watching. We end our discussion today. If you like this video, like it, share it, and don't forget to subscribe the channel. Thanks for watching.